Hi there, and welcome to our video. Today we'll talk about descriptive statistics, such as the mean value, the median, geometric mean, variance, or standard deviation. You may think, why the hell do we need so many different statistics? Well, each of them has a special purpose. Let's break it down in a very simple way. We're not going into equations, as you have software for the calculations, but we need to know when to use which statistic. In principle, there are two groups of descriptive statistics. Those which describe the average or the typical value of your dataset, and those describing how much variability is in your data. Those statistics describing the average show you where your data is typically located on your measurement scale. So let's replace this with location. By the way, the statistically correct way would be to talk about measures of central tendency. But to make it simple, let's just talk about location and variability. Now, to know what the most typical value of your data is, you can have a look at the distribution of your data. In case of normally distributed data, the mean value describes the center of this distribution. It is also the most frequent value. The correct term would be arithmetic mean, because there are also other mean values. Hence, for normal distributions, the arithmetic mean is a perfect measure for the location of your data. Now, consider your data is not normally distributed. For example, let's assume you measure the distance that people walk per day. Then your data may look like this. This is a log normal distribution, which is skewed to the left. Most people walk only a few kilometers, larger distances are much less frequent. If you calculate the arithmetic mean here, it doesn't describe our data very well. Since we have a log normal distribution, another statistic works much better. It's the geometric mean, or geomean. If you plot the geomean into this distribution, then it describes the center much better than the mean. The, let's say, trick of the geomean is the following. We have log normally distributed data here, but we can transform them back to a normal distribution by calculating the logarithm. Then the transformed data follow a normal distribution again. And now we can also transform the geomean the same way. And the beauty of the geomean is that when we transform it, we obtain the mean value of this normal distribution. In simple terms, the geomean in log normal space corresponds to the mean in normal space. So to wrap up, the geomean is useful when you have log normally distributed data. Other very useful descriptive statistics are percentiles. We could, for example, calculate the value below which half of our data is located. The other half would be located above this value. This is called the 50th percentile. 50% of data are below and 50% of data are above this value. The 50th percentile is also called the median. In particular, when we have skewed distributions, like this one, the median is very useful because it has a very clear meaning. 50% of data are lower and 50% are higher. Now let's mention the next statistic, the mode. The mode is simply the value which occurs most frequently. If you have such a distribution, it is simply the peak of the curve. The mode is most useful when you have counts of categories or discrete numbers, for example, counts of votes for a candidate. Note that there may be several categories which are equally frequent, hence you can have more than one value when you calculate the mode. Finally, there is the harmonic mean. The harmonic mean is a perfect statistic when you want to calculate averages of rates or ratios. Imagine you take a train from London to Paris at a speed of 100 km per hour. On the way back, the speed of your train is only 80 km per hour. And now you want to know the average speed of your journey. Intuitively, you may think that your average speed would be 90 km per hour, but that's wrong, because speed is measured in kilometers per hour, distance per time. And the train was driving more time at 80 km per hour than at 100 km per hour. To obtain the correct average speed, just calculate the harmonic mean, which is 88.89 km per hour. In case you're interested, in mathematical terms, the harmonic mean is the reciprocal of the arithmetic mean of the reciprocals. Now let's jump to statistics describing the variability of your data. The statistical term for these is measures of dispersion. So they describe how much your data is dispersed around the average. A dispersion measure you are certainly familiar with is the standard deviation. It is used for normally distributed data. The advantage of the standard deviation is that it describes the variability of your data in the same unit as the mean value. Hence, it is very easy to interpret. If you see such an example, you immediately understand that there is a lot of variability in group A, much more than in group B. When plotting data, the standard deviation is often shown using error bars, but don't mix them up with standard errors. That's something very different. The latter are measures of uncertainty, similar to confidence intervals. We will cover measures of uncertainty in another video. A benefit of the standard deviation is that it is clearly defined. About 68% of the data lie within ±1 standard deviation from the mean of your normal distribution. Hence, everybody can interpret it. So for normally distributed data, the standard deviation is a perfect measure of variability. But don't use it if your data is not normally distributed. A related measure is the variance. The variance is just the square of the standard deviation. It is much less useful than the standard deviation because, since it's squared, the variance does not have the same unit as your data or as the mean value. So usually we don't use it. But then you may ask yourself, why does the variance exist in the first place? Well, there are special cases when the variance is useful. For example, when you have more than one independent variable and you want to estimate the overall variability, then the variance has the benefit that you can do more maths with it. You can just add up variances to obtain the overall variance, and you can't do this with the standard deviation. But these are rare cases. In most cases, we just use the standard deviation. We've seen that variance and standard deviation were only designed for normally distributed data. So how do we describe variability or dispersion if we have non-normal data? You can use percentiles. We have already learned that the 50th percentile describes the value below which 50% of the data points are located and above which the other 50% of data points are located. To describe variability, we can, for example, calculate the 10th and the 90th percentile. This gives us an impression about the spread of our data, the dispersion. In this example, we can directly see that the data points are very dispersed around the median, and we can also see that there is a skew to one side because the 10th percentile is much closer to the median than the 90th percentile. So for non-normal data, use percentiles to describe variability. So that was a brief description of descriptive statistics. Here is an overview of all the statistics we talked about today. Maybe you have some examples of datasets for which you would like to know how to describe them best. Then just leave a comment and maybe make a proposal of which descriptive statistic works best. Thank you for watching, and if you liked the video, please like, share and subscribe.